If ABCD is a parallelogram, which statement would prove that ABCD is a rhombus? So, what makes a parallelogram a rhombus? A parallelogram becomes a rhombus the moment its diagonals are perpendicular to one another. So, if I have ABCD, right? Whenever you're drawing a geometric figure from a description, you will always have to either draw the figure either in a clockwise orientation or counterclockwise orientation, and it really doesn't matter which orientation you choose, just as long as you're consistent with it, and the outcome will all be the same. Another feature that turns a parallelogram into a rhombus is if all the sides are congruent. So not only are opposite sides congruent, but all the sides are congruent. And then the last feature is the diagonals actually bisect all the various angles. So let's see if any of the descriptions here matches, or any of the options matches the description that I just made there. So looking at option 1, we have angle ABC is congruent to angle CDA. ABC congruent to angle CDA. Well, this is true. However, that is not unique to that of a rhombus. It is already true for a parallelogram. Opposite angles are congruent, so that option 1 there is not good. Option 2, AC is congruent to BD. That is not a requirement. So the diagonals in a rhombus do not have to be the same. The only time when diagonals are congruent is if the parallelogram is a rectangle or a square. So that's not good. Option 3, AC is perpendicular to BD. So the diagonals are perpendicular to one another. That is what we were looking for there. That fits that bill, right? AC is perpendicular to BD. And then option 4, AB is perpendicular to CD. AB is perpendicular to CD. Well, that just doesn't make any sense because AB and CD are opposite sides. They cannot be perpendicular.